Solar geoengineering is a term that sounds like something pulled directly from a science fiction novel, yet it has become one of the most debated topics in modern climate science. Much of the public conversation surrounding this technology has been sparked by the involvement of high-profile figures like Bill Gates. Gates has provided significant funding for research projects at institutions like Harvard University, specifically focusing on how we might artificially cool the planet. The idea is born out of a sense of urgency. As global temperatures continue to climb and international efforts to reduce carbon emissions struggle to meet their targets, some scientists believe we need a backup plan. This is not about cleaning up the atmosphere or removing greenhouse gases, but rather about managing the amount of sunlight that actually reaches the Earth's surface. It is a radical shift from traditional environmentalism, moving from the idea of conservation to the idea of active planetary management. The specific method that has gained the most attention is known as stratospheric aerosol injection. To understand how this works, you have to imagine the Earth's atmosphere as a layered shield. Most of our weather happens in the lowest layer, the troposphere. Above that is the stratosphere, a calm and stable region where very few clouds form. Scientists propose using high-altitude aircraft or specialized balloons to release tiny, reflective particles into this upper layer. These particles, often made of sulfur dioxide or calcium carbonate, would create a thin, invisible veil around the globe. This veil acts like a mirror, reflecting a small fraction of incoming solar radiation back into space. By reflecting even just 1 or 2% of the sun's energy, we could theoretically offset the warming caused by decades of industrial activity. It is essentially an attempt to create a permanent, controlled dimming of the sun to keep our climate stable. While the idea of intentionally polluting the upper atmosphere might seem dangerous, it is actually based on a natural process that humans have observed for centuries. We know this works because we have seen it happen after major volcanic eruptions. In 1815, the eruption of Mount Tambora in Indonesia released so much ash and sulfur into the stratosphere that the following year became known as the year without a summer. Crops failed in Europe and North America because the planet cooled so significantly. More recently, in 1991, the eruption of Mount Pinatubo in the Philippines lowered global temperatures by about half a degree Celsius for nearly 2 years. These events provided the proof of concept for solar geoengineering. Scientists realized that if nature could cool the planet by accident, perhaps humans could do it by design. The goal of current research is to see if we can achieve that same cooling effect without the catastrophic side effects of a volcanic explosion. There are several reasons why this technology is being taken seriously by people like Gates. The most significant advantage is speed. Most climate solutions, such as transitioning to renewable energy or planting trillions of trees, take decades to show a measurable impact on global temperatures. Solar geoengineering, by contrast, could start cooling the planet within months of being deployed. This could be vital if we hit a tipping point where melting permafrost or collapsing ice sheets threaten to cause runaway warming. Another factor is cost. Compared to the trillions of dollars required to overhaul the global energy grid, the cost of flying planes into the stratosphere is remarkably low. It is one of the few climate interventions that a single wealthy nation, or even a very wealthy individual, could theoretically afford to do on their own. For some, it represents a necessary insurance policy against a climate catastrophe. However, the disadvantages and risks associated with solar geoengineering are profound and have led to intense global opposition. One of the primary concerns is that we do not fully understand how messing with the atmosphere will affect global weather patterns. The Earth's climate is an incredibly complex system where everything is connected. By cooling the atmosphere in one place, we might inadvertently shut down the monsoon rains that billions of people in South Asia and Africa rely on for food. There is also the issue of the sky itself. Adding enough particles to reflect sunlight could turn our blue skies into a hazy, milky white. Furthermore, this technology does nothing to address the root cause of global warming, which is the high concentration of carbon dioxide in our air. Even if the temperature stays cool, the oceans would continue to absorb carbon dioxide, leading to increased acidity that kills coral reefs and disrupts marine life. Perhaps the most terrifying risk is a phenomenon known as termination shock. If a global cooling system were put in place and maintained for several decades, the underlying greenhouse effect would continue to build up behind that reflective shield. If the system were to suddenly fail or be shut down due to war, terrorism, or political instability, the cooling effect would vanish almost overnight. The planet would then experience all the stored-up warming of the past several decades in a matter of years. This would be a temperature spike so rapid and intense that most species, including humans, would likely struggle to adapt. It creates a situation where once we start, we might be forced to continue forever, regardless of the consequences. This creates a moral hazard, as some worry that having a technological quick fix will reduce the political will to do the hard work of cutting carbon emissions. The governance of such a project is another massive hurdle. Because the atmosphere belongs to everyone, no single country has the right to decide the temperature of the entire world. A temperature that is perfect for the United States might cause a devastating drought in India. There is currently no international framework or law that dictates who gets to control the thermostat. This could lead to a new type of global conflict where nations blame each other for every drought, flood, or heat wave. Critics also point out the ethical concerns of a few wealthy individuals or nations experimenting with the life support systems of the planet without the consent of the global population. This is why many scientists have called for a non-use agreement, arguing that the technology is too dangerous even to test in the open air. At this stage, solar geoengineering remains largely confined to computer models and small-scale laboratory experiments. The project funded by Bill Gates at Harvard, known as the Stratospheric Controlled Perturbation Experiment, faced significant pushback from indigenous groups and environmentalists when they proposed a small test flight in Sweden. The flight was ultimately canceled, highlighting just how sensitive this topic is. For now, the world remains divided. Some see it as a dangerous distraction that allows us to keep burning fossil fuels, while others see it as a desperate but necessary tool to prevent the worst effects of global warming. It represents the ultimate human ambition, the attempt to take full control of the Earth's climate. Whether that ambition is seen as a miracle of engineering or an act of extreme arrogance depends entirely on how much faith one has in our ability to predict the consequences of our own actions. The conversation is no longer about if we can do it, but whether we should ever dare to try. It is a decision that could define the future of our species and the planet itself.